If you're watching this video, I assume that you want help with stoichiometry. So as part of my video series for my classes or anybody else out there that needs help, here's a video on stoichiometry. And if you're wondering where this stuff comes from, I use the book Modern Chemistry by Holt, Reinhardt, and Winston. So anyway, as far as stoichiometry goes, what's one of the more important concepts in chemistry, it basically involves all of Chapter 9 in the Holt book, and then we use it further on in other parts of the course. But basically what it is, the purpose of stoichiometry is that you take a balanced equation. And if you have a balanced equation, I can convert from any product, any reactant in that balanced equation to any other reactant or product. Okay, and I can convert moles, I can convert mass, I can do whatever I need to do. And the trick is to use something called the mole ratio. Okay, now I am assuming that up to this point you guys know how to balance equations, so I'm not going to go over that. Okay. Next, I also am assuming that you guys know how to convert from mass to moles and moles to mass. So step number 2, I'm not going to go over, nor will I go over step number 4. But there is something new that we need to introduce here, and that's step 3, which is called the mole ratio. And the mole ratio is more or less the heart and soul of stoichiometry, and it's the step by which I convert from, again, one reactant or product, any reactant or product, to any other reactant or product in a balanced chemical equation. Okay, so these 4 steps is something that I learned in high school and something that I've been teaching here for several years now. The steps are: number 1, you have to balance the equation. So that's, again, review. Step number 2 is that you got to take your starting materials and convert them to moles. Now that may or may not be done for you. So you have to pay attention on whether you have to do that or not. That's why it says if needed. And step number 3 says use the mole ratio, and that the mole ratio comes from the coefficients of the balanced chemical equation. Let me say that again. The mole ratio comes to the coefficients of the balanced chemical equation. And finally, we're going to convert to mass, and that's if needed. And that's review 2. And if you're following the Holt book, that's typically around chapter 3 for most textbooks, high school textbooks. Okay, so let's jump right in here and let's see if we can't do some of this stoichiometry stuff. All right, let me get to a full screen here. That might not work out to be the best. Okay, carbon dioxide reacts with lithium hydroxide to produce lithium carbonate in liquid water. How many moles of lithium hydroxide are required to react with 20 moles of CO2? So what I tell my students to do, and what I suggest to you guys do out there, is to follow the 4 steps of stoichiometry. So step number 1 is to write a balanced chemical equation. So it says carbon dioxide reacts with lithium hydroxide to produce lithium carbonate and liquid water. I'm also assuming that you guys know how to write formulas correctly. Okay, so this is again chapter 7, chapter 8 of how to do writing formulas and balancing equations. All right, so to balance this equation, I need a 2 in front of the LiOH. Okay, and that should do it. All right, now I also would suggest that if when doing stoichiometry, you only know one number, and that one number we know is 20 moles of CO2. So let's write that down. I have 20.0 moles of CO2. Okay. Now, step number 1 says balance the equation. That's done. Step number 2 says convert your starting materials to moles. You'll notice I'm already in moles, so step number 2 is done already. So what I need to do is move on to step 3. Now it's a mole ratio. Mole ratio means moles over moles. Okay. So what I'm going to do is convert. I'll address it later. I'm going to convert from moles of one thing to moles of another. Okay, so we have moles of CO2, which is 1. Now, this mole ratio is also a step by which I have something completely different than you've seen before. You could have a number other than 1 in the mole ratio, and the reason is these numbers that in the mole ratio come from the coefficients of the balanced chemical equation. So if I have moles of CO2 here, I better have moles of CO2 on the bottom so they can cancel out. How many moles? Well, I have 1 up here, so I'm going to transfer the 1 down here. And then it asks for how many moles of lithium hydroxide are required, so I'm going to go to moles of lithium hydroxide on top. And again, how many moles of lithium hydroxide? In this case, I'm in the mole ratio, so I'm going to transfer the 2 from the balanced chemical equation down to the mole ratio, and I end up with a 2/1 ratio. Step number 4, do I have to do it? Step number 4 says convert to mass. Well, the question says how many moles of lithium hydroxide? I'm in moles of lithium hydroxide, so I'm done. So 20 times 2 is 40 moles of lithium hydroxide. That's stoichiometry, okay? I converted from one thing in a balanced chemical equation to another thing in balanced chemical equation, okay? All right, let's move on. Let's try another one. All right, during photosynthesis, plants generate glucose, which is C6H12O6, and oxygen gas from carbon dioxide and water. What mass in grams of glucose is produced when 3 moles of water react? Okay, so step number 1, write a balanced chemical equation. All right, plants generate glucose, so they generate glucose and oxygen gas from carbon dioxide and water. Okay, so balancing this, I need a couple 6's in here, and that should do it. So step number 1 is done. Step number 2, convert your starting materials to moles. You'll notice that I'm already in moles with 3 moles of water, so I'm done as far as that goes. So step number 2 is done. Step number 3, I always have to do step number 3. It's the mole ratio, and I'm going to have moles of water. Oops, I put 1. It's not 1. Moles of water on the bottom, because I have moles of water there, so it's got to cross off on the bottom. And then it says what mass in grams of glucose is produced. So I got to convert to moles of glucose. So all I'm doing is paying attention to what is written in the problem. Okay? So I'm doing what the problem asks me to do. All right, so where did the numbers come from in the mole ratio? They come from the coefficients of the balanced chemical equation. So I have 6 moles of water in the equation, so I better have a 6 down here. I have 1 mole of glucose, so I better put 1 mole of glucose there. Now, step 3 is done. Step number 4 says, what mass in grams? So I got to convert to mass. So I'm going to go the 4th step of stoichiometry. And the 4th step is I'm back to 1 mole again. Only in step 3 will you have a number other than 1 when it comes to moles. Step number 2 and step number 4, you're back to 1 mole again. Okay? The molar mass of glucose is 180.0 grams of glucose. And when I, C6H12O6, and when I multiply, let's see, 3 divided by 6 is 0.5. When you hit equals, it's 0.5. Take 0.5 times 180, and you end up with 90.0 grams of C6H12O6. So you notice I've labeled everything in the problem. I've labeled my answer. Nothing is left to chance. Okay? Let's try another. All right, so I have a chemical equation at the top here where ammonia plus oxygen gives me nitrogen monoxide plus water. How many moles of NO are formed when 824 grams of NH3 react with excess oxygen? Okay, so I have 824 grams of NH3. Again, you only know one number, so write it down. Step number 1 is done for you. I'm sorry, it's not done. It's not balanced. And in order to do this, I need to balance out this equation. And I'm going to do it very quickly here. This one is a little bit more of a tougher one to balance. But it happens to be, I'm just looking this up, 4, 5, 4, 6. Okay, so that should work out as far as the balanced chemical equation goes, but you would have to do that on your own, just remember. So I write down my starting materials. You'll notice that this is kind of a new one here. I have to do step number 2. I'm in mass, and I got to get to moles. So I'm going to take, NH3, excuse me. I need to take the molar mass of NH3, which is 17 grams, probably put 17.0 grams of NH3 under 1 mole of NH3. So this is the first time in this lecture that you've actually had to do step 2, just to point that out. So the grams cancel. Now, I did step 2, I'm in step 3. So I have moles of nitrogen on the bottom, or excuse me, moles of ammonia on the bottom to moles of NO on top. So again, just reading the problem tells me where to go. So when I write the mole ratio, again, a 4 goes from here down to here, and a 4, ironically, goes there. Okay, so it's 4 over 4. And then it says how many moles are formed of NO. I'm in moles of NO. I do not have to do step 4. I am done. So 824 divided by 17 times 4 divided by 4 gives me 48.4 moles of NO. Okay? All right. That's another problem. Let's try one more. I think this is the last and final problem. This is the hardest of the hard. This is the all 4 steps. So if you can do these kinds of problems, you got this done. All right, it says tin 2 fluoride found in toothpastes is made by the following reaction, which is balanced. How many grams of SNF2 are produced from the reaction of 30 grams of HF? Okay, so let's write down our only number that we know, 30 grams of HF. Okay, step number 1, balance the equation, done. Step number 2, I'm in mass, so I have to convert from mass to moles. So this is about 20 grams of HF. That's the molar mass of HF, is just mass of 1 hydrogen plus 1 fluorine. So I have step number 2 done. Step number 3, I always have to do, it's the mole ratio, and I have 2 moles of HF on the bottom, just matching them up, and I'm going to moles of SNF2, so that's 1 mole of SNF2, and I'm getting these numbers from the balanced chemical equation. All right. It says how many grams of SNF2 are produced, so I got to go to step 4. I have 1 mole of SNF2, and the molar mass of SNF2, let me look it up quickly. The molar mass of SNF2 is 156.7 grams of SNF2. Okay, so when I take 30 divided by 20, I hit equals, divide by 2, hit equals, and then multiply by 156.7 and hit equals, I end up with an answer of 117.5, or something close to that, depending on how you rounded off your molar masses. Okay, so again, let me reiterate. The purpose of stoichiometry is to take a quantity of something in a balanced chemical equation, any compound, any molecule in a balanced chemical equation, and I can convert to anything else in the balanced chemical equation by using this process of a mole ratio and stoichiometry. So it's very, very useful. If you have questions, let me know. You can message me through Twitter. You can email me, whatever you need to do. Okay, thanks.